Welcome. So this question says a 6 kilogram car moving on a flat horizontal track makes a turn of radius 2 meters. 0.8 coefficient of static friction exists between the tires and the track. What is the maximum speed the car can have while driving around the track? So it's a circular track. So let's visualize. So let's look at the track from above. And the radius is 2 meters. And it's a 6 kilogram car. And what we have to add to this is the fact that we have a force of friction pointing towards the middle of the track. And we also have to add in there's a centripetal acceleration pointing towards the middle of the track. So why is the force of friction pointing towards the middle of the track? And the reason for that is that the car wants to continue in a straight line because of its inertia. And if you had no friction, it would continue in a straight line. The fact that it is moving to the right is because there's a force moving it to the right. Friction tends to oppose the tendency of motion. And if the tendency of motion is to kind of move like that, your frictional force must be like that. I'm not sure that's explained very well, but the frictional force is to the center. And why is it also a static friction? And that is an important point, actually. The tire does not slide across a road unless you're really, out of control. The tire rolls over the road, and when you get a situation where the object above is not sliding across the object below, then you're in the static mode. You're in the kinetic mode when the object above is sliding across the object below. So this is actually a static friction situation, even though the object is moving, even though the car as a whole is moving. So okay, we look at this and now we try to figure out what's going on, and we say, well, the sum of the forces horizontally is equal to MA, and we recognize in this case it's going to be MAC because it's circular motion, which equals MV squared over R. So then we look here and we say, oh, I don't know what the force of friction is, so let's figure that out. I know that this is 6 kilograms, so we have a 60 Newton weight, and so I know that my normal force is also 60 newtons, and we have this frictional force here. So we say, well, FF is equal to mu Fn, so we can say FF is equal to 0.8 times 60, so FF is equal to 48 newtons. That's the maximum static frictional force that we can get out of our system. Let's just close this off. That's one little side calculation. So then I say, well, okay, that's pointing to the right, so plus 48 is equal to the mass, which is 6, times the velocity, which is what I want, squared, over the radius, which is 2. So V squared is equal to 48 over 3, which equals 16. So V is equal to the square root of 16, which equals 4 meters per second. And there it is, 4 meters per second. So what did we do? We read and visualized, and we were careful, as always, to mark down any forces, any accelerations, any distances that were important. We recognized it was a circular motion question. So we recognized it follows. This is all Newton's second law. The sum of the forces equals ma. So the sum of the forces along this axis equal ma, which equal, because it's centripetal mass times centripetal acceleration, which equals mv squared over r. And then we substituted in the appropriate numbers and got our answer. So there we have it.